それではこれより午後のセッションを開始いたします。2014 Vision for OpenStack Networking and MidoNet と題し、ミドクラコファウンダー and CEO ダン・ミハイ・ドミトリュウ様よりご講演をいただきます。なお、当セッションでは同時通訳がございます。チャンネル1番で日本語をお聞きいただけます。同通レシーバーがお手元にない方はスタッフがお配りいたしますので挙手をお願いいたします。それではどうぞよろしくお願いいたします。
Hi, good afternoon. My name is Dan Dimitriou, and I'm the co-founder and CEO of MidoCura. And today, I want to talk about a few things. I tried to come up with a presentation that is partially forward-looking, besides talking about our own product and our own solution. So first, I'll just give an intro to our company, and then talk about some of the trends of the IT infrastructure that's driving network virtualization and cloud overall. And I'm going to give some of my predictions for 2014, about what's going on in our industry, and particularly around networking. I will also talk about SDN and OpenStack around Neutron, and what we're working on there. And I'll also give a brief demo of MidoNet and Heat, so that I think is one of the more exciting things that is working in the latest OpenStack release. So our company was founded in 2010. And initially, we were actually started a business to build a cloud service provider here in Tokyo in 2010. However, we decided to actually change to a pure software company model as we discovered the need for this network virtualization in the context of cloud, public and private. And when we did that, of course, our universe expanded beyond the Japanese market here, and we became a much more international company. So we set up an office in San Francisco and Barcelona. We're very much focused on the network virtualization for infrastructure as a service cloud. That's always been our main focus area. And last year, in 2013, April, we closed our Series A round, which was actually invested by NTT Group, NEC Group, and INCJ. Okay. We've been working closely with Red Hat on a Red Hat Enterprise Linux and certified our solution against their platform. And we actually work with multiple vendors of cloud, not only OpenStack, in fact, but Red Hat Enterprise Linux is our main platform. And this year, we actually joined last year in the summer, we joined the Open Daylight project, which is yet another open source community that's focused on SDN, where we believe we actually can have a lot of good impact, and also collaborating in the community, we can build some exciting solutions. That was actually just a couple of weeks ago, the Open Daylight Summit, where we presented our integration with the Open Daylight controller. Finally, one thing about our approach is we have a completely distributed architecture, so there is no bottleneck or centralized controller that can be a single point of failure. One of the criticisms that we've heard about SDN is that it introduces this kind of centralized control model that actually could have a negative impact on availability. So we've been trying very hard from the very beginning to avoid such a thing. So let me talk about some trends in IT infrastructure that makes all of this cloud stuff extremely relevant, and now particularly about the network aspects that we're focused on. So what are the biggest CIO challenges? Right? The biggest CIO challenges are basically making applications go to market faster, so increasing agility. So services and applications are moving to the cloud, but the network has actually been lagging behind. It is possible right now, has been possible for a while to virtualize the compute. And then storage is also doing fairly well in terms of being able to be provisioned on demand. But the networking is still very much lagging behind. Network hardware gets very expensive as they scale up. So you have to be pretty smart about the way that you architect your network. And also, a lot of products are actually have a strong vendor lock-in component because of maybe they use some proprietary protocols or because they have various proprietary APIs that people get used to. But agility really remains the biggest challenge here. So in the era of cloud, the network is really a big problem because of the way that if you use a traditional network and then try to run this type of cloud on top of it, there are various problems that are going to come up. Big problems. Partially, we're going to have underutilized resources because we're going to be always placing compute resources on the basis of network constraints. The provisioning aspects are actually the biggest problem. So manual provisioning is still the bane of the cloud in the enterprise infrastructure. So that is the user experience, particularly for the administrator, but also for the business owners, the application owners, needs to be improved. Networks don't scale with dynamic workloads, which is what the cloud is all about, after all. And it's just not possible to get to that instant provisioning dream with the current architectures. So application owners, as I said, application owners actually seek agility. So it's all about time to market, going through the dev, test, staging, and deployment cycle as quickly as possible. And at the same time, infrastructure owners, they seek security and control because they don't want to give full control to these untrained application owners, right? They don't have all the information. They're not fully responsible for the infrastructure. And network virtualization can actually help both sides. Network virtualization coupled with some policy mechanisms that we'll talk about later can actually provide the agility to the application owners and control to the infrastructure operators at the same time. So network virtualization maybe means a lot of things to different people, so I just want to talk about our views about how this has evolved over the last several years since we've been involved, since we started the company and even before that. So traditionally, networks, Ethernet networks, have had some mechanisms for isolating multiple tenants from each other. One such mechanism is VLANs, right? So virtual LANs on Ethernet, it is an isolation mechanism, layer 2 isolation mechanism, but it's really not sufficient for cloud for a variety of reasons. One is that it's static and typically manually configured, which may have been improving in the last couple of years. It's complex, and layer 2 domains basically are single failure domains. So if you have anything going wrong inside one of your layer 2 domains, the whole thing is out. Like if you have a loop, for example. So it's really not appropriate. Finally, in terms of scalability, even though VLANs do provide a certain form of isolation, they still keep all of this state inside the network that's proportional to the full tenant state. In other words, every single virtual machine in the system will create some kind of address or some kind of data all the way inside the core of the network. So as we said earlier, we want to push most of the intelligence to the edge of the network. We don't want everything to stay in the core. So next came OpenFlow. And OpenFlow, the intent of OpenFlow to separate the control plane from the data plane is good in terms of the provisioning aspects. But it doesn't really address the fundamental issues that just by programming the state inside the network, we still have the same problem. We have not really separated the application, the tenant state from the actual core of the network. It's still the same amount of state in the network. Finally, we have come into the era of overlays. And overlays are the solution that is now gained acceptance as the right way to virtualize networks for cloud. Overlay networks are not new. There's a lot of layering going on in networks for a long time, particularly in service provider networks with MPLS and such. However, overlays have come into the data center relatively recently. So with new things like VXLAN or GRE or whatever your favorite IP encapsulation is, we can solve the problem of this network state exploding in the core. With the overlay approach, we just keep only the most minimal physical state inside the core of the network, and all the virtual network state is at the edge. Okay, so now I just want to make my predictions for 2014. What is happening in our industry and how our perceptions of networking changing. So first of all, I think the edge of the network is finally going to become the most important place that we're focused, rather than the core. In the world of networking, the core was where most of the innovation and the focus has been for a long time. And the most interesting products are there because the core of the network is complicated and needs to be very, very fast and robust. So that's understandable. However, putting the complexity of networks that are required for cloud into the core is not the right approach. And as more of the functionality moves into software, which runs on x86 at the edge, so the focus will shift from the core of the network to the edge. And we're already seeing some of this happening in some innovative architectures. For example, Deutsche Telekom in some of their deployments are running layer 3 routing all the way through to the servers, which is great, right? So we don't actually do any layer 2 at all in the core of the network. And of course, they use the hypervisor to hypervisor overlays to create the isolation, edge to edge. So in other words, isolation doesn't happen in the core of the network anymore. We've taken that out entirely. Overlays are now, I think, pretty much the accepted way to build this type of cloud virtual network isolation. We've been in this for several years, and I think at least even a year ago or 6 months ago, people are skeptical about the performance implications of overlays. But that skepticism, I think, is largely no longer there. Now it's a question of when, not whether or not this is the right approach. So some of the reasons for actually doing edge-based overlays are to gain a lot more flexibility in two areas. One is in how the core of the network is built and architected and managed, and then also how the virtual layer of the network is architected and managed. Secondly, enforcing application policy makes sense to do that at the edge, right next to where the application is running. And some of the work that's going on in Neutron these days is addressing exactly that issue, application policies. Another major trend in 2014 is the increasing importance of ODM manufacturers of switches and servers. So you may have noticed that in a lot of rankings of market share, there's a category of other than the big brand name server vendors. And the market share of that other has been going up and up and up steadily. In fact, it's actually something like 20%, of some ODM manufacturers have 20% market share in certain segments, even though, their names are not famous. And in networking, they've also started to make an impact there. Right, so these ODM vendors are providing hardware that is incredibly inexpensive compared to the brand name manufacturers, and up to a certain extent, their functionality has been questioned in the past. Is this good enough for my network? But again, since the functionality and the complexity is moving into software that's largely running at the edge, it doesn't matter so much what the core is able to do as long as it's able to forward IP reliably and cheaply. So on a very closely related note, we've been working closely with our partner Cumulus Networks. And Cumulus is providing basically a Linux distribution for the switch. So another one of the major trends I think that's going to happen is that networking devices, physical devices, start to get managed just like servers, using the same tools like Puppet, Chef, the various monitoring tools that are well known for servers are being used for the network as well. Will be used for the network as well. And running Linux, a standard, very standard open version of Linux on the switch devices is the first step in that direction. Finally, in 2014, I think we're going to start seeing a lot more production use cases of cloud, private cloud, and OpenStack. From our experiences in 2013, we did a lot of POCs, and we had a lot of instances of users basically testing things out or trying it in dev test. And in 2014, things are moving beyond curiosity to, let's get this into production and run real workloads on it. So this is actually happening for OpenStack, and at the same time I believe it'll happen for the network virtualization as well, broadly speaking, in the enterprise. For my final prediction, I think that we're going to start seeing some serious consolidation in terms of OpenStack distributions. So, every major vendor is either already has a OpenStack distribution or is launching one. But just like the Linux distributions of 10 plus years ago, consolidation is definitely going to happen. In fact, we've already seen one or two weaker players drop out of the market of OpenStack distributions. My money is on Red Hat Enterprise Linux, personally, for being the dominant player. I think there's probably room in the market for, 2 or 3 perhaps, but one of them will surely dominate. Okay, so next, I just want to talk about SDN and OpenStack networking and what it is that we're doing in the Neutron world. So originally, Neutron was just a component of OpenStack, which basically was refactored out of the core Nova code base. But Neutron is really evolving to the point where it stands on its own potentially as a product. Neutron offers an attractive and stable northbound API that provides a certain amount of investor protection. So that users are not locked into any one product. So I think these days it's pretty much the de facto standard, and it's demanded by customers that, well, do you support the Neutron API, for your northbound? Of course we do. So we see Neutron as the place where multiple network services will be available, again via standard northbound API. So we're not talking just about the basic services of layer 2 or layer 3 connectivity, but also higher level services like firewalls, load balancers, VPNs, and such. We think that open source and the commercial products can coexist very happily in this environment. And again, we're actually doing some work to help facilitate more choice in terms of network services. Currently in Neutron, it's a little bit, there are the open source implementations that are already there, and then some vendor implementations that are plugged in, but it's very hard to choose to switch back and forth between them, and I think that's one of the pieces of work that needs to be done in the next couple of releases. So we already have customers using MidoNet, our product, via Neutron API. And in fact, some of them don't even use the entire OpenStack suite, like Nova and the rest of the services, because they had their own homegrown things. They had their own homegrown cloud systems, but those did not include a networking component. So just a brief intro to our MidoNet architecture. MidoNet is a distributed overlay-based network virtualization platform. So we have a series of agents that run between that run on all the hypervisor hosts and gateway nodes. And these agents together implement this overlay that provides isolation, as well as some network services that are built directly into MidoNet itself. We run all of the functionality at the edge so that there are no bottlenecks or extra hops that could be single points of failure or bottlenecks in the system. There is a central component, which is the network state database. It's centralized, but actually replicated for fault tolerance and scalability. And that provides the network topology, the REST API, as well as the data gathering for analytics that the customer can use for visibility into the network. So some of the value that we add to Neutron, the base implementation and the open source components, are a layer 2 gateway that provides VLAN mapping, layer 3 gateway that provides BGP interface. That's for, in both of these cases, these gateways can be scaled out so that if the network traffic increases beyond the capacity of a single box, you can just add more dynamically. And in our latest release, we've added a layer 4 load balancing service, which is, again, also fully distributed. It doesn't have any appliances that are going to get in the way or introduce extra hops. And what we're trending towards is we want to build an elastic service platform for other third-party vendors to put services on top of Neutron. So the MidoNet Layer 4 load balancer, which you can stop by our booth later on and take a look at. Basically, we all know what a load balancer does. We take traffic in Layer 4 TCP traffic, and then we spread it out over a series of virtual machines that are implementing the back end. In our case, we actually do not introduce any appliances, physical or virtual, to do this. So the agents themselves actually have this layer 4 load balancing functionality built in, so that all the traffic flows go directly from source to destination without any extra hop in between. So this is one thing that we've added into our product, and it is also available via the LBAS, load balancing as a service API in Neutron. Okay. Another thing that we've done is we've integrated MidoNet with OpenStack Heat, which is the templating mechanism for OpenStack, for multi-tier applications. And we actually have a little demo of OpenStack Havana with MidoNet that we want to show right now. Basically, provisioning a multi-tier application and then showing how that dynamically creates the network resources on the in our product, in our MidoNet product, that's integrated via Neutron. Okay. So this is a brief video, which we'll start playing here. Okay. So the heat templating demo, we start off by looking at the Horizon interface, and there's actually no instances, no networks in this tenant, right? In this view as well. And then in the MidoNet GUI, we take a look at the configuration. Again, the tenant doesn't have anything there. So now we're going to create a 3-tier application from a template file. Okay. Right, and we're going to launch this multi-tier application, and now we're going to check to see how the provisioning is going. Okay, there's the network in Horizon. Okay, and then we fast forward, and now we have the network for our multi-tier application. Right. We still have to set up the routing, I think, between our tiers here. And we look in the MidoNet GUI, and we can see that the same network resources were created there. Sorry, the speed on this video is a little fast. So now again, we connect the routing between the different tiers of our application. And we can see our instances were created as well. And then we actually create another. Right. Again, we check the routing. Then this is our MidoNet GUI. So the same resources as were provisioned in OpenStack by Heat are available through the MidoNet interface. So now we create another instance of the same template. And again, we can see that the virtual network resources are automatically created. So this is pretty cool. I mean, I think Heat in Havana now has come to a point where it's really possible to provision these multi-tier applications very, very easily. Okay, and now we're gonna shut down the. We're gonna delete these instances. Okay, and that's it. So if you'd like to see that at a slower pace, please come to our booth later. Okay, so in 2014, we're doing quarterly releases of our software, and we're going to have our next release at the end of Q1, and this one will be integrated with OpenStack Havana and notably certified on Red Hat OpenStack 4.4. And it's also going to be including this layer 4 load balancing service integrated with LBAS, as well as a few other features. In Q3, we'll have our Icehouse-based, our Icehouse compatible release, which will also support VXLAN tunneling and VTEP gateway. And the VTEP gateway is actually a layer 2 hardware-based gateway, which could be one of several vendors like Dell or one of the ODM switches running Cumulus. So we can do a hardware-based layer 2 gateway interface. And then finally, we integrate more services into our platform, like VPN as a service with IPsec VPN, supporting like an Amazon VPC-like model, as well as firewall as a service API, which is implemented in our distributed firewall in MidoNet. So I want to talk about a couple of important OpenStack community initiatives that MidoCore is involved in. MidoCore is actually the #1 contributor in terms of startups with under 20 developers. So we're still pretty small, but we're doing a fair amount of work in OpenStack. So right now we're working on the group policy API, elastic load balancing, providing choice of service vendors per tenant for network services, as well as the service VM. So Currently, the network services are run as in network namespaces. That doesn't work well for third-party virtual appliances that weren't necessarily built on Linux. So group policy is very interesting. Group policy is still in the POC stage in Neutron, but we expect that to be out in the Juno release. This basically greatly simplifies the commands needed to set up a network with an application policy. So this is meant basically to replace security groups with a much better mechanism for implementing policy. Security groups, as you know, is the mechanism that's been around in AWS for a long time. The problem with it is that it describes the actual connectivity policy with very low-level constructs, like IP and port. So what we're looking for is a way to describe policies in a much more abstract way. So defining sets of connectivity groups, like the web tier, the application tier, or the database tier, and defining the policy directly on that. So we're actually working on this project very actively, and we're going to be implementing it very early in our product, of course, so that when it comes out as an API in Neutron, we'll be supporting it from the start. So operators deploying OpenStack with MidoNet will be able to use a much simpler language for application policies than they do right now with security groups. So this is just to give you an idea of what the policy looks like. Basically, we group the virtual machines into these different connectivity groups and then describe the policy of connectivity and security in terms of the entire group rather than on a IP address basis. Next is elastic load balancing as a service. So there is an LBAS implementation currently in OpenStack, which is based on HA proxy, and it's been very successful. But compared to AWS's ELB service, it has a major limitation, which is that it is not actually elastic. It's a single instance. So that kind of defeats the purpose of the elastic load balancing. When we have something at scale and we really need to scale the application, which we can actually do now very easily with heat and Silometer, we need the load balancing to be scalable as well. So earlier I described that in our latest release, we now have a layer 4 load balancing service. So later on this year, we're going to extend that to actually support layer 7 with SSL offload and all that. So again, then we'll be able to do full layer 7 load balancing that automatically scales out, just like the Amazon AWS. Finally, the tenant choice for network services. So as I described earlier, one of the issues in Neutron right now is that the drivers for network services like LBAS and firewall as a service, VPN as a service, they're actually loaded up at the boot time of the entire cloud. So you can't actually change the choice on a per tenant basis after that. So one of the things we're working on for hopefully Icehouse, maybe not, maybe the next release, is to be able to make a per tenant choice of network services and actually have multiple drivers active at the same time. So for example, if somebody's using OpenStack with MidoNet, and some tenant might want to use MidoNet's built-in load balancing function, or another tenant might want to actually use a third party, like a virtual A10 or F5 inside the cloud. So that is not possible today. It's something that we think should be available because we'd like to have the users have the choice of using whatever vendor's implementation of service they want. And making that happen actually also requires the service VM work to be done, which we are actually currently working with the community in which Intel is also heavily involved. being able to run service instances in a full KVM virtual machine rather than in a network namespace, which is what's currently done. I don't know if the term NFV came up these days, but NFV is actually the motivator for Intel to make the service VM actually work. And so we think that's actually going to happen in OpenStack and will be very beneficial to private enterprise cloud users as well. Okay, thank you very much. And please fill out the survey form and do drop by our booth later on. And we'll be happy to talk further. Thank you.
ダン様ありがとうございました。